All right, welcome back from the Weekend Bulldogs. I hope you had an awesome weekend. Today in Algebra 1, we're going to continue with this idea of area as a sum and as a product. So we're going to finish up our notes for section 3.2.2 and continue on with the first part of the notes for 3.2.3 with some examples I'm going to show you. What we're going to do today is I'm going to first go through a summary of the Desmos activity that you worked through over the weekend and on Friday with me. I'm not going to touch on all of the slides, but there are a few that I want to highlight for you and talk about some of the different ideas that I want you to take away from that activity. So we'll go through that together. The second thing that we're going to do is I want to show you some more examples of generic rectangles where we are expressing the area as a product and as a sum. And I want to help you see that connection between using these rectangles to multiply out the two parentheses that form our product, and the answer to that multiplication problem is the sum from the area of that rectangle. The last thing we're going to do is I'm going to talk about a small homework assignment I'm going to have you do to keep practicing these ideas and also review ones that you've learned before. So let's get started. Keep playing the video, pause it when I ask you to work through some examples, and at the end then you can use the rest of class time to work through your homework. On Friday, I had you work through an activity in Desmos that had you explore the connection between the area of a rectangle being its length times its width and the area being the sum of the smaller parts or the smaller rectangles that make up the larger rectangle. So for example, this rectangle that's shown here, we can show it being its area being a product of its length times its width. So in this case, one dimension is 2 plus 3 or 5 times the second dimension, which is 8 plus 2 or 10. Okay, so that's one way to show the area. Or we could show the area as a sum of these four smaller rectangles inside of the figure. And so what I want to do is go through some of these slides with you just to kind of help summarize what you learned in this activity or should have taken from this activity in class and then also over the weekend as you finished it on your own. So I'm going to skip ahead here to slide 6, and this was an activity we did in class together, but I'm just going to review. Okay, for this one what you're doing is you're taking each picture, you're matching it with a product, and then finding the total sum. Okay, so for this particular rectangle, we need to take a look at the dimensions, length times width. Okay, and so one of the dimensions of this rectangle is 4 plus 2, and the other dimension is 4 plus 1. So this right here, that product representation represents the area, length, times width of that rectangle up above. And then if I take 6 times 5, that gives me a total area of 30. Now in this program, I found out after class, in order for it to give you credit, you gotta like stack them over top each other like that so that it matches it up and connects them together. So it's fine. I'm going to go through and check each one for you guys anyway. So don't worry if you didn't do that. I'll catch that when I manually check it. All right, for this particular rectangle, all right, going across the bottom, we have a dimension of 2 plus 1, 2, 3, 4, 5, 6, 7, 8. So 2 plus 8. And then vertically, we have a dimension of 4 plus 6. So that's this right here, 2 plus 8 plus 6 plus 4. Okay, so I'm going to line those up. There we go. And then if we find the total area, we've got 10 times 10 or 100. My third picture, along the bottom, I have a dimension of 4 plus 5. And then vertically, I have 3 orange blocks plus, let's see here, 3, 4, 5, 6, 7, 8, 9. It looks like 9 blue blocks. So that would be this one right here. 4 plus 5 times 9 plus 3. And so that's 9 times 12, which is 108. And then for this last one, horizontally, we have a dimension of 4 orange plus 3 blue, and vertically 3 orange plus 2 blue. So that would be represented by this right here, 4 plus 3 times 2 plus 3, and that gives us a total area of 7 times 5, or 35, okay? Now in the next set, 7 through 12, now all of a sudden these grid lines inside are gone. So let's take a look at slide number 8 here, okay? Notice our grid lines are gone, but we can still figure out the area as a sum and as a product, okay? So for example here, okay, if we take a look at just the outside dimensions, my vertical dimension has a length of x units plus 2 units. And so we type that like this, x plus 2. Okay, that could be one of the dimensions, length or width. And then the other one, the horizontal dimension, is x in the blue plus 6 more units in the orange. So x plus 6. Okay, and that's what it wanted you to type in this box. Now I'm going to tell you, we can also figure out the area as a sum by figuring out the area of these little individual parts, and that's what we're transitioning to today. So I'm going to change the directions on this one and add in a little bit extra of my own. For this top blue block here, the area of that blue block, length times width, is x times x, or x squared. I'm going to have to get creative. Let's see here. I think it will let me do, yeah, look at that. Okay, x squared. All right. Then if I take a look at this orange block here, okay, it has a vertical dimension of x and a horizontal dimension of 6. Length times width, x times 6, that's another 6x units I have to add in there, okay? Moving down to the bottom row, this orange block here has a dimension of 2 by x. So length times width, 2 times x is the area of that small part. And then the final blue rectangle here has dimensions of 2 by 6, 2 times 6, or an area of 12. So we just represented the area of this rectangle as a product, the outside dimensions, length times width, and as a sum of those 4 inside rectangles. Let's try another one together. Let's take a look at 9. Okay, here they want us to drag the points to create a visual for x plus 5 times x plus 8. So I need to make this have 5 on a side, and this one x, plus 8, okay? And so now they want us to enter the total area of the grid. Well, they already gave us the product as a sum, x plus 5 times x plus 8. And now we'll do the area as a sum. This box here, again, x times x, that's x squared. And then this orange box on top, it has dimensions of x times 8, so that's plus 8x. The orange box on the bottom has dimensions of 5 and x. 5 times x gives me 5x. Whoops. And then the last box here has a dimension of 5 vertically and 8 horizontally. 5 times 8 is 40. Again, we just represented the area as a product and as a sum. Okay, one last time here. use the draggable points to create x plus 9 and x plus 11. So I'm going to move this up here, x plus 9, and then x plus 11 right there, okay? Total area. Again, they gave us the area as a product. And the other way we can calculate the area is add a sum. This top blue box here has one dimension of x and another one of x. Length times width, x times x, is x squared. We'll add to that the next box, this orange one right here. It has a vertical dimension of x and a horizontal dimension of 11. X times 11 is 11x. On the bottom here, this orange box, a vertical dimension of 9, horizontal dimension of x. 9 times x is 9x. And then the blue box here, vertical dimension of 9, horizontal of 11. 9 times 11 is 99. And so again, we represented the area as a product and as a sum, okay? Now what we can do is we can simplify this and add the 11x and the 9x together, and we're going to start doing that in the second half of the lesson. But for now, I just want you to focus on how do we find the area as a product and how do we represent it as a sum of its parts, okay? And so then you had some challenges that followed, all right? So for each of these, we're taking a look at, again, the picture. We're writing the area as a product and also as a sum. So we're going to go through that right now. I'm going to make these a little bit bigger so we can see these, okay? So our first picture here, okay, on one side we have dimensions of x plus 3, and on the other one we have x plus 8 units. So it's this one right here. I'm going to add that there, okay? And then if we do the area as a sum, this little box, x times x, is going to give me x squared. This box here, x times 8 is 8x. This box here, 3 times x is 3x. So if I take that 8x plus the 3x, I get 11x. And then 3 times 8 is 24. X squared plus 11x plus 24 is the area that I want. I'm going to move some of this stuff over here, okay, so we can take a look at another picture. Let's take a look at this one right here, okay? Area as a product, x times x is, area as a product, we're doing length times width. So x plus 8 units, x plus 8 units. So that's this one right here. I'll move that guy over there, okay? Then for the area as a sum, we have x squared for this top block here, x times 8 or 8x over here, 8 times x or another 8x, so now I'm up to 16 x's, and 8 times 8, which is 64. So this guy comes over here. Let me put this back on top there. Okay, good. All right, next picture. Let me move some of these over here so we can get them out of the way. Okay, so this one, we've got x times x or x squared, x times 9, which is 9x, 7 times x, which is another 7x's, so 9x plus 7x gives me 16x, and 7 times 9, which gives me 63. So this is the area as a sum. And let me find that other card. Where did that other card go? Hang on. Right here, okay? So we know that one's definitely in there. I'm going to pull this out for a minute until we figure out the rest of it, okay? We'll just set that there. Make this a little smaller so we can see everything. There we go. Okay, and then for the area as a product, x plus 7 units, x plus 9 units. Okay, and so that goes there. And so for here, these should be our last cards. Let me move this over here so we can see. Okay, we have the area as a product, x plus 4 times x plus 6, and the area is a sum, x squared plus 6x plus 4x, which gives us that 10x in the middle, plus 24. Okay, so these go with this one. And then the last two, I don't know why that's not matching up, but it should. Okay, the last two here are just more challenges where you're moving things around and you're forming new rectangles, okay, and coming up with more of those areas. And then you've got another challenge here where you're doing the same thing, combining, figuring out the length, figuring out the width, writing the area as a product and as a sum. All right, so that was the Desmos activity that you had to do. And what I'm going to do now is I'm going to switch to some other problems from the book that I'd like to work with you through to help you understand this idea. And I'm also going to have you try some on your own during this notes video that I'll explain later. All right, so in the last lesson, 3.2.2, when we were building these rectangles using the algebra tiles, we started working with this idea of expressing an area as a sum, and then also rewriting the area as a product. So here we have an example of a rectangle we might have built with algebra tiles. We talked about how we could add up all the parts and pieces to express the area as a sum. So for example, we've got 1x squared tile, we've got 1, 2, 3, 4, 5, 6 x tiles, and 1, 2, 3, 4, 5, 6, 7, 8 unit tiles. So the area as a sum is x squared plus the 6x tiles plus the 8 unit tiles. We also said we could express the area of a rectangle as its length times its width. So here, one of the dimensions, okay, is x plus 1, 2, 3, 4 units. Okay, don't forget this x squared tile is x by x on each side, and the smaller side of these x tiles is each 1 unit long. So that's where we get the x plus the 4 units from. Okay, on the other dimension, again, this x squared tile is x units long, and each of these is 1 unit on a side, so that's where the plus 2 comes from, x plus 2. So we can also express the area as a product. It's the length times the width, x plus 4 times x plus 2. In section 3.2.3, problem 3-54 has us do just that, again, with some generic rectangles. We're given, or we have to find rather, the dimensions for the length and width of each rectangle, and then write the area as the product of the dimensions and as the sum of the tiles. So these bigger square tiles, these are going to be our x squared tiles. These rectangles here, these are all going to be our x tiles. And of course, these are going to be all of our unit tiles, okay? So for this first one, I'm going to start with the area as a sum. I have 2x squared tiles. I've got 1, 2, 3, 4, 5, 6, 7 x tiles, so plus 7x, and 6 of those unit tiles, so plus 6. Now, if I want to write the area as a product, I have to find the length and the width of the rectangle. So along the bottom side here, I've got 1x plus another x. This part right here is 2 x's plus each of these is 1 unit on a side, 3 units, okay? Taking a look at the other dimension here, okay, I've got 1x right here, and a length of 2 units. So my area as a product of length times width is 2x plus 3 times x plus 2. I apologize, my worksheet that I uploaded into this program doesn't give me a ton of room to write. All right, take a look at B, okay? Area as a sum. This is an XY tile right here. This one is going to be an x squared tile. How do I know that? Well, take a look at the x tile right here, okay? That tells me that this is x on a side, all right? And here I have another x tile, so that's going to be x on a side. That's an x squared. And then I have a bunch of x's and y's. These are all y's right here. These are all x's. And this is an x, and then my unit tiles, okay? So I'm going to start with area as a sum, okay? We've got xy plus an x squared tile plus 1, 2, 3, 4, 5, 6 x tiles plus 1, 2, 3, 4 y tiles plus 8 unit tiles. Okay, that's my area as a sum. And if I want to do my area as a product of length times width, then I need my dimensions, okay? This tile right here, the XY tile, might be the trickiest. It's X on this side, Y on this side, okay? And I can tell because of the Y tile that it backs up to right here, okay? So there's a Y, there's a length of X right here, and then these put together is a length of 2. So Y plus X plus 2 is one of my dimensions. And then the other dimension is X plus all of these units here. Remember, the Y tile is a Y by 1 on its side. So this length here is 4 units long. So times X plus 4. All right, so now we're going to try something different. We're going to start with the product, and from that, we're going to create our own area model. Okay, we're gonna skip the algebra tile part and start simplifying this a little bit and just go with a generic area model using the dimensions that are given to us from the product. And then we're going to use this to help us write the area as a sum. So let's take a look at what that looks like. Our first product is x plus 3 times 2x plus 1. That means for our rectangle, we're going to use x plus 3 as one of the dimensions, maybe the length, times 2x plus 1, which we could consider our width. So here's what our area model looks like, okay? We're just going to draw a generic rectangle, doesn't matter what the size is. Okay, and I'm going to split it into 4 parts. Scaling doesn't matter, okay? The whole idea is that on one of the sides, maybe the vertical side, one of the parts represents X units, the other part represents 3 units. Going across the top, one part represents 2X units, plus the second part, which is going to represent 1 unit. This is how we draw a generic rectangle without using the algebra tiles. We skip that middle part, we skip drawing in all the sections inside, just draw a general rectangle where one dimension is split into a part that's X units long and the other part is 3 units long, and the other dimension having one section that's 2X long and the other section that's 1X long. How will we use this? Well, now what we're going to do is find the area of each rectangle inside of the larger rectangle. In the top left corner, we have a rectangle that has a dimension of X and a dimension of 2X. X times 2X gives us an area of 2X squared. Top right, I have a rectangle that has one dimension of X and the other dimension of 1 unit. X times 1 is just 1X. Bottom left corner, we have a dimension of 3 and a dimension of 2X. 3 times 2X is 6X. And the bottom right, we have a dimension of 3 and a dimension of 1. 3 times 1 is 3. How do I write the area as a sum? It's the sum of all the parts. 2x squared plus x plus 6x plus 3. And then I should combine these two together for a simplified area of 2x squared plus 7x plus 3. And of course, that is equal to the original area written as a product of x plus 3 times 2x plus 1. These generic rectangles are helping us multiply this product and figuring out what its equivalent sum is. Let's take a look at the next one. 2x times x plus 5. That means I need to draw an area model that has one dimension of 2x. No need to split it into parts. I don't have an addition sign in between the 2 and the x. The second dimension, though, has a part that's x, and then a second part that's 5 units long. Okay, let's use this to figure out the area as a sum. The first block has dimensions of 2x and x, or 2x squared. The second one has dimensions of 2x and 5. 2x times 5 is 10x. So the area as a sum is 2x squared plus 10x, and that is equal to the original product of 2x times x plus 5. So in other words, we just used that area model to help us multiply 2x times x plus 5, and we find that it's equal to 2x squared plus 10x. What I'd like you guys to do is try these next two problems on your own. So pause the video, try these problems, draw out your generic rectangle, use that to multiply the two parts together, and rewrite the area as a sum. We'll come back together and check your work in a minute. Okay, let's check your work. I'm going to draw a generic rectangle for the first one. I need one dimension to have a length of x, the other dimension to have a length of x plus, I need it to have a dimension of 2x plus y. Going to find the area of each individual part. X times 2x gives me an area of 2x squared. X times y gives me an area of xy. So my area can be written as a product, x times 2x plus y, or as a sum, 2x squared plus xy. I can use my generic rectangle to multiply those two together and end up with that sum. For the second one, I need one dimension to be split into two parts, and the other dimension is going to be split into 3 parts. So vertically, I'm going to have my dimension as 2x plus 5. Horizontally, x plus y plus 2. Figuring out the area of each individual square. 2x times x gives me 2x squared. 2x times y gives me 2xy. 2x times 2 gives me an area of 4x. 5 times x gives me an area of 5x. 5 times y gives me an area of 5y. 5 times 2 gives me an area of 10. Now notice the top right box right here and the bottom left box right here are both x terms. We're going to be able to combine those together when we write out our final area as a sum. What does this tell us? This process tells us that the product 2x plus 5 times x plus y plus 2 is equal to 2x squared plus 2xy plus 9x, I got that from taking the 4x plus the 5x, plus 5y plus 10. What I'd like you to do now is I'd like you to complete the review and preview from section 3.2.2. I know we're jumping back a section from these notes. We're not quite through with the notes for this section. I'll finish with that with you the next day, the next video that I share with you this week. So for right now, your homework assignment is to finish the review and preview for 3.2.2. And I'd like you to take a picture of your work and upload that into this assignment tab so that I can see how you're doing with these ideas. Don't hesitate to email me if you have a question.